Laser pointer. Okay. Okay. We ready to get started, Gary? Or? Okay. I want to apologize to Chris Leichtweis and the rest of you. We had some technical difficulties, so we're starting a little bit late today. But I think we finally got it worked out. This is Chris Leichtweis. He's the founder and CEO of Safety and Ecology Corporation. It's a business located out towards the technology end, out towards Oak Ridge. Chris has a Bachelor of Science in Engineering Physics. He's a native from New York. He got it from State University College of New York at Brockport. He's been in the Tennessee area for 16 years. He founded his company in 1991. He's not only the CEO, he's also the senior industrial hygienist, senior health physicist. So he's going to tell us a little bit about what his company does, help you to our campus.
Well, thanks, Dr. Hines. Thank you all thank you for your patience today. Again, my name is Chris Leichtweis. I have a company here I started back in 1991. It's about 350 employees or so it's turning into something that to talk about these days. And it primarily does radiological support services across the country, as well as nuclear remediation and hazardous waste remediation. Let's get started. This is our corporate headquarters here. We just moved into our operations building right over here, which houses about 75 engineers, some of which are nuclear engineers. We pretty much have invested back into the company. All of our profits over the last 10 years or so, we do about $35 million in revenue. All our retained earnings are back into our organization. We reinvested back into the people and the facilities, so we're real proud of that. Over here, we'll talk about our laboratory. It's more in terms of a instrumentation, calibration, and maintenance facility. So I don't have any pictures, but we'll be talking more about that. This is the outline for today. We're going to talk a little bit about SEC, and then I'm going to go over some of the definitions of nuclear remediation and some of the elements, so that I don't completely talk over your head. This is pretty simple stuff once you get the terminology. We're going to talk about some of the historical nuclear cleanup activities in the U.S. that I've personally been involved in, and some of which that I haven't. And some of the focus of what's the market analysis summary, what does that mean to you as a nuclear engineer if you choose to go in this direction. And then our specific experience, some examples I'll give you, and I'll talk about some case studies that we've done, or one particular case study at the Oak Ridge National Lab. It was a cleanup we did out there, finished last year. And then some of the opportunities you all can be looking at and looking forward to, and then maybe what we can do is set up some possible internships for you, and I'll give you some information with regards to that. Back in my basement in March 11th, 1991, I started SEC, and today we've grown to 357 employees to be exact. We're in the top 100 environmental firms in the country, 87 to be exact, and this year we're going to be doing about $35 million in revenue. We're one of the largest companies out of Knoxville that bases their headquarters here. We're in the top 30 largest companies. A lot of people don't know we're here. We're very much wrapped around the Department of Energy programs across the DOE complex. We're also doing a lot of commercial work, which we'll talk about. We just got done with a film that Pat Summerall, he actually came to Knoxville and filmed us. We were awarded the Industry of Champions National Program as an emerging company in this business, and actually Pat came and filmed us, and we have a 6-minute videotape about our company. I should have brought it with me. We could have played that today. It's kind of interesting. He doesn't pronounce radiological very well on the tape, and it really irritates me. He's a little football. I just hope he lives long enough so it's worth get some mileage out of this video. He doesn't look too good. These are our core competencies: radiation protection and survey. We're the largest radiological support service contractor across the Department of Energy. We run all the radiological support programs all the way up to the senior management at all 3 Oak Ridge facilities, up at Fernald, the Portsmouth facility, and also the Paducah facility. And we're also in some capacity at about another 20 sites within the DOE complex and so forth. Industrial hygiene, I'm a certified industrial hygienist. We also provide those services. Safeguards and security, which I think will, unfortunately, we're going to be seeing a lot more work in that regard. That's something that we're getting involved with at border patrols and also at airports. We'll talk about that. Nuclear remediation, facility decommissioning and decontamination. We're going to talk about that today. And some of the laboratory programs we have, we actually provide on-site laboratory analysis, both alpha and gamma spectroscopy at these facilities, these large-scale projects. And then some of the environmental remediation and construction work that we do. We're a Tennessee Superfund contractor, for example, so we also get into the hazardous side of the house as well. And then we also use many technology applications that we have to either develop ourselves or utilize from other companies, or even Oak Ridge National Labs has actually provided us some technologies that we've used. We have 4 entities within our corporation: professional and field services. That's where most of our engineers, senior engineers, our consultants, things like that fall out of that particular group. Environmental remediation, we do about $10 million in that business. Infrastructure management and development, what that is, that feeds both of these first 2 items, and that is more acquiring hazardous waste and radiological contaminated sites. We transfer the liability to SEC. We actually clean the site up. We develop the property, and we either sell it back to the original owner or we'll sell it to somebody else. And then our safeguards and security program. Professional services, I've already explained. This fellow here, you'll see again, this is a radiological survey being conducted at Niagara Falls storage site. It's a very large site. In fact, I started my career at the Niagara Falls storage site, hence I'm from New York, kind of connect. This gentleman's got handheld radiological instrumentation tied to a GPS system where we're actually recording data, radiological information of the soil contamination and pinpointing that to a geographical location so the report can be printed out and ready to go. And actually what you get is what you'll actually see GPS survey maps of intensity maps is what we call them. What's hot, what's contaminated, and what isn't. And it's kind of nice. A lot of people don't have the advantages of what we do in understanding a lot of this. Environmental remediation. The only real pertinent information here is that we're getting into things that do not pertain to this presentation, but bioremediation is a very exciting new industry. Unexploded ordnance, groundwater remediation, and emergency response. For example, under the emergency response, the Department of Energy is just starting to ship the special nuclear material from Westphalia, New York. We were awarded the contract to actually ride in the cars and trail the trains and all those shipments all the way out to Idaho Falls. So that will be, hopefully there isn't going to be an emergency response, but we're there just in case. Here's the mix of people in our organization. Notice the nuclear engineers. We've got about 10 or so nuclear engineers in our organization. We're growing in that area, and I'll tell you why in a minute. There's about 800 certified health physicists in the country. We've got 6 of them here locally, and you can see the radiological control technicians and industrial hygiene technicians, which make up the bulk of our organization. Very, very much involved with the radiological aspects of things happening around across the country, both commercially and in the government. Instrumentation, these are typical. There's a handheld instrumentation. It's a Ludlam 2221. Here's some air monitoring equipment, all of which, here's a gamma spectroscopy system. We own about 4 or 5 of these, and we actually mobilize on site with trailers and or fixed locations on site. You know, what's been left over, and as far as housing and stuff, we'll set up our gamma spectroscopy labs. All of this is managed and run out of our organization here in Knoxville. We also manage, repair, calibrate, maintain all the instrumentation for the 5 facilities that Oak Ridge operates out of. That's Portsmouth, Paducah, and 3 facilities here in Oak Ridge. Lots to do. Some other remedial action experience. We have a Tennessee Superfund contract. We're into our 5th year of that, 4th or 5th year. We've been doing an awful lot of work here. We've done 5 radiological cleanups on that contract, 4 of which have been here locally in East Tennessee, as you would expect. Bethel Jacobs, we have a $30 million contract. We just started. We're doing work in cleanup activities of about $1 to $3 million worth of value per project. We're going to talk about the Manhattan Project cleanup. This is the one that I just alluded to in Niagara Falls storage site. This is the formerly utilized site remedial action program. This is a $3 billion plus remediation program that's still ongoing. That's all. The project was actually begun back in 1978. I got involved in '82. There was 49 sites. About 20 sites have been cleaned up. There's essentially, 29 sites to go. The Tonawanda site and the Maywood sites have been split off. Those are both of which we support. Those are major $300 to $500 million cleanups. So we've made a mess and we're cleaning it up. And these are mostly building contamination, soil contamination, groundwater contamination. So these are real problem sites. Brookhaven National Laboratory, we've done several remediations up there, and also some high-tech nDNA survey, non-destructive testing and analysis of several boxes of contamination. So it's a non-intrusive means of sampling. You don't have to go in and expose people. You can actually count the box. So that's a neat little system we've worked with Canberra to develop. And we actually successfully completed about a $2 million characterization there on a lot of boxes. Dr. Jacobs, we just finished this. This is a non-red site. I'm not really sure why I mentioned that, but this was more asbestos and lead. Right along the New Jersey, what I call the radiopharmaceutical chain, there were several cleanups that we did of laboratories, small-scale laboratories. Millstone was our first commercial nuclear power plant. We had to go up and perform the radiological characterization, the actual survey of units 1, 2, and 3. This is one of many facilities, and this is why you all need to be really listening closely, because there's aging facilities out there in the commercial nuclear world, all looking for nuclear engineers. They're looking for people that understand the systems. Obviously, the complexity of the systems in Millstone are such that you really have to understand what you're dealing with so you can survey, map out what you're doing. But we conducted the radiological survey in about a year and a half at Millstone. This is a $3 million contract we just won in Minnesota. This is an Army ammunition facility, what we call TCAP, and that's a building D&D and soil remediation. Maine Yankee, some of you know Jim Berger. Maine Yankee is utilizing our services from the standpoint of final status survey. After the cleanup is done, who can go in and actually provide an independent review of what's been done and survey accordingly. The University Test Reactor, here's another example. We're into the universities. This is about a 2 kilowatt reactor, and we're just beginning to support this activity. This is about a $2 million cleanup as well for us. Here's an example. I mean, when we end up with cleaning up these facilities and these buildings, you can imagine the enormous amount of volume associated with volume of contamination. These are the ways. This red line illustrates 50,000 cubic yards of material we've moved from on rail cars. Just over the last 5 years, of bulk material that's contaminated that usually would typically it goes to EnviroCare, Utah, not right next door to Clyde, Utah. We were just talking about that earlier. Kind of give you an idea of the New York accident last week. They have removed less than 10,000 cubic yards in the last 7 days. That kind of puts things in perspective of how much material we've been moving over the course of the last 5 years. You can see also a trend here where trucks are becoming less popular, rail is becoming more popular because we're getting into a lot of the large-scale remedial actions. There's been more money available up until last week, and we've been using, obviously then the bigger projects have been funded and so forth. Okay, two pieces of, there's a difference between remediation and D&D. And what I mean by remediation is this is more the environmental cleanup. This is usually, when we refer to remediation in our industry, it's usually EPA, Corps of Engineer, and DOE cleanup activities. In the D&D arena, and these are synonymous terms, really, but it's usually more people who have either laboratories or they may be a smelter that possess a radioactive license, and they have to terminate that license, and they refer to that under 10 CFR 20-1401 as a D&D term. So I'll be using those synonymously. I didn't want to confuse you guys. Okay, cleanup activities. What it comes to is, you can see I keep mentioning dollar value. This is a big business, and there has been about $8 billion spent so far on some of these programs I've talked about, but there's about another $150 billion worth of work. So anybody who's looking for a career path, this is certainly one that's feasible for you. There's going to be a lot of work in this area. And politically, it's not a real popular thing to have low-level radioactive waste in somebody's backyard. And often that's where it ends up. Or they have built and developed residential properties, often in New Jersey and in Salt Lake City and in other places across the country. People are they actually use the uranium mill tailings, or they've used some backfill material from the original facility to actually build and construct housing on these in these areas. So you can imagine the political ramifications of that. Well, here's 6 or so different types of nuclear cleanup programs that are out there. The Site Decommissioning Management Plan, the FDMP sites, there's about 60 of them. We're going to talk about that. We've participated in cleaning up some of those. The Commercial Nuclear Reactor D&D license termination, there's 109 or so facilities out there, all of which are coming to full term, so obviously the commercial nuclear business is going to be looking for people like you to assist in the decommissioning of those programs. UMTRA and FUSRAP, I've worked on both those projects. Those are both billion-dollar projects. UMTRA has completed its, for the most part, is done. FUSRAP is ongoing. Other DOE facilities, now that the Cold War is over, Oak Ridge is being taken down for the most part. K-25, for those of you that are local here, or the East Tennessee Technology Park, basically will be greenfield in the next 8 to 10 years, theoretically, providing the funding is there. And then there are others such as laboratory cleanups and so forth. Army ammunition plants are becoming on the radar screen now. We've got artillery ranges that utilize depleted uranium that's scattered all over the place. We've got lantern metal cleanup, thorium-232 cleanup. We're just starting one up in Camden, New Jersey right now. It's about a six-year contract for us there. So lantern metal is an example of commercial usage and obviously cleanup. So taking these programs, we've supported 6 sites in the FDMP. We've been involved in 3 in the commercial nuclear power, and primarily the 3 that we've talked about. Millstone I've talked about, Manyankee I've talked about, and Big Rock. We have some senior people in our organization that are respected across the industry, and they're called often for this the commercial nuclear D&D activities. Jim Berger's one, Ed Walker's another, and so forth. UMTRA and FUSRAP, we've been involved in 12 sites on UMTRA, 49 on FUSRAP, and here's some examples of how many sites we've done there. We've been involved in a couple of hundred different remediations of nuclear radiological remedial activities across the country. $8 billion has been spent on these projects, and the key focus in the future is FUSRAP within the Corps of Engineers. The Department of Energy has lost, actually the project was transferred over to the Corps of Engineers, and there's 20 sites remaining. We're on several of those sites right now. Commercial nuclear power. I just pulled a quote that said 45 of the nation's 109 nuclear power plants were licensed between 1962 and 74, and they've been running for more than 23 years. And so many of them these relics are from the atomic age and are literally cracking apart long before their 40-year license are set to expire. There are problems. There are things that we have to be doing. There may even be an interim measure of D&D and remediation. But they're calling us often to take a part in that activity. Okay, let's move along here. Kind of gives you an idea of the we've done 150 facilities, 1,000 buildings, and we've done that. You first have to, before you get into this, you have to perform a radiological characterization. We have people in our organization that specialize in nothing but that, in total survey and measurement of these facilities. And we have a lot of rapid survey methods that we utilize, such as, big floor monitors and things we can do large area scans, and the GPS system I talked about earlier with our handhelds. Final status survey. The gentleman, Jim Berger, I mentioned earlier, actually wrote a lot of the regulation associated with final status survey. Once you identify what the contamination is, you go in and remediate the contamination, okay, you remove it, you dispose of that contamination, then you have to survey it, and it's usually done by an independent contractor. Jim Berger wrote the standards for that, and now there's a multi-agency document that goes across the regulatory gambit of EPA, NRC, DOE, Corps of Engineers, and now everyone's gotten to agree on how that final status survey should be performed, and then you do, obviously, a radiological closure, all of which, in some of these elements, if you're involved in the RAD characterization or the D&D, you do not do the final status survey. That's typically an independent contractor that does that. Okay, so radiological characterization, we have to determine the source term typically. And what I mean by that is what's the radiological makeup of that particular contamination. It could be all different kinds of radionucleodes. And for example, in a analytical laboratory, it is done just in a sundry of different analysis. You may never know. So you have to do a RAD characterization of that to determine what we're dealing with. So there's surface and waste release limits depending upon the isotope. So that's very important to determine what the source term is. Obviously, doing risks analysis. Sometimes we don't have release criteria for building surfaces, so you have to establish those based on a risk, and there's many codes that you can use there. And they also have to determine waste volumes and the ultimate D&D cost to the client. Okay? Here's an example, as I talked about the Millstone power plant up in Connecticut. We did about 1.2 million cubic feet that we characterized, 75,000 sample points. We analyzed 1,500 through gamma spectroscopy, 1,500 samples. This is an example of a report. We may identify systems here, green being clean, red being contaminated, just to kind of give them an idea of what kind of a cost analysis they can, what it's going to ultimately cost them in the long run. Here's an example of an intensity map by GPS handheld equipment that we were using in Niagara Falls. You can see our intensity maps, maybe the red indicating right there the contamination. Well, that was at the River Valley. This is up in this is the Corps of Engineers site in Marion, Ohio. Actually, I think we stole that picture just to demonstrate the kind of what it looks like, the kind of GPS survey. Now here's one that we did in '94. These are 350,000-gallon tanks of it had heavy metals, and it had all kinds of had some fission products, and it also had some natural occurring material. They went from process to process at Brookhaven National Labs and utilized these tanks for many different things. This is about 30 MR per hour around the tanks. And what we had to do is build a sprung structure. We actually enclosed all these tanks. We enclosed these tanks so we could use plasma arc torches and actually cut them up, box this material, and actually ship it through the Panama Canal to Hanford for ultimate disposal. This is about a $4.5 million contract, but from a Wallowa standpoint, man-rem estimate standpoint, we burned out a lot of people. We had people all in supplied air and things, and there wasn't anything fancy about this necessarily, but it was very tricky in terms of exposure. Lots of shielding was used in some of the staging areas where we cut up the tanks. Okay, here's a case study in Oak Ridge National Labs. This was to remediate, this is an example of about $1 million remediation out here. It's very typical of what I call an environmental nuclear or radiological cleanup at X10 or Oak Ridge National Labs. This involves both the OHF tanks and ponds area and also the process waste sludge basin. There was actually two ponds that we had to take care of. I think there's a picture here. Yeah, here it is. This was the basin here, which was a pond. This was another pond down here. What we had to do is consolidate these two actually stabilize the waste, the sludge within the ponds, and stabilize it down here at the OHS tanks and ponds. What's going to happen here is there's going to be a complete cap over this entire area eventually, and that's what's going on right now. So we had to consolidate some of the contamination. This is the OHS tank and pond that we actually ultimately brought the basin material down after we stabilized it, and we stabilized it in place there using very conventional methods. A little bit about the pond. It was constructed back in 1963. It was probably about a quarter of a football field in size. They had to keep about 6 feet of water on top of the pond filled up so it would attenuate any of the gamma exposure. The external exposure was, when we lowered the pond by every foot, it increased about 30 ml/h. So obviously, in order to stabilize it, we had to dewater it. So you can imagine the levels of exposure on our workers, which leads us to methods and how we did it. Here's a look at the pond, the basin, the process waste sludge basin here. We dewatered this. This wasn't as high level as the OHS tank and pond, but what we had to do here is dewater and then actually mix it with lime material, stabilize it, load it on trucks, bring it down to OHS tank and ponds, and actually mix it. Excavate, transfer, consolidate it, backfill, cover, and regrade both the pond and the basin sites, and restore it to natural grade is really what we are after here. Here's an example. Here's some of the lime we were using, mixing it into after we dewatered the basin, actually mixing it with a very long hose here, about a 50-foot, 65-foot hose, something like that, because of external exposure. We had to get the largest one we could find and actually mix it. This is kind of a high-tech meets low-tech project. Load it onto a truck. You notice the liners here. We were unsuccessful in keeping this particular truck from being contaminated, but we did our very best. These buckets here never made it out either. These buckets all remained contaminated. Here's an example of a 55-foot boom track hoe mixing the material. This is the soil cover over the OHF tank and pond area. That's the before, and that's the after. Again, this will also receive another large cap eventually. And as I alluded to earlier, decontamination is always very important. Heavy equipment becomes contaminated. This is really not a high-tech project in that you have to use very conventional equipment. But this is what remediation is all about. Okay. R&D, remediation, D&D opportunities for nuclear engineers. This is where I see you all and how you could perform work for us. This is what our nuclear engineers do for us. Often understanding commercial nuclear power or test reactor systems and how to dismantle those systems. We obviously, Dr. Hines gave me a tour downstairs. You've got some little mock-up reactors. Obviously, understanding the systems, we have to know how these systems are made up and how to characterize, what to do volume estimates within those systems and how to dismantle. Criticality analysis, we're constantly doing criticality analysis for some of the plutonium challenges we have out at X10 and at Rocky Flats. Ed Walker is one of our criticality specialists, and he does the old conventional way with pen and our paper and spreadsheets, but there's all kinds of Kino code models and stuff for you all to utilize. Survey and measurement design, or as I alluded to, the non-destructive assay that we use, we actually roll up with a gamma spectroscopy system on wheels, and we can click and count boxes to determine what the source term is in those boxes, so that we can prepare for shipment to 3 or 4 facilities that are available. Safety analysis. Safety analysis is very big. You have to categorize various buildings within the government as well as outside the government as to what type of level of contamination does the building have and what type of categorization does it need, because then that throws in all kinds of safety measures that you have to deploy. And also transportation support. One of the nuclear engineers that have graduated from here actually is one of our transportation people, and he's a specialist in determining source term and providing that on the manifest. Okay, employment opportunities. Basically, send your resumes to recruiting@sec-tn.com or long@sec-tn.com. She's one of our recruiters in the Human Resources Department. Next year, I went over and talked to the operations group. We're projecting about 3 to 7 employees. We're going to need nuclear engineers, about 3 to 7 of you, in the coming year. And also, I want to encourage you all. We're interested in doing some interns as well. I think that you can see that although we do use conventional methods, it's not always that way. We also need very bright people to do all kinds of survey and design of instrumentation and other ways to, and also commercial nuclear power that we're getting into. We have to use the expertise that you all have to get the job done. But anybody who's interested in interns, I encourage you to write a 3-page white paper and send those in before those deadlines if you're interested. We'd love to do an intern with you all. Okay, questions?
Do you use any robotic systems?
Yes. We're just starting at the building 3019B. It's a hot cell at Oak Ridge National Laboratories. We're using a robot. Because of the perchloric acids in the hood, they're up above, and also it's laced with, I'm not sure what the source term is. It's a laboratory. No, it's a hot cell. So, but we're using robotics to go in there and actually take the intrusive samples. We're trying to characterize the HVAC system to see what they've got. And then ultimately, about the next 18 months or so, there'll be a remediation piece on the street. Robots are often used. Ed Walker with us, TMI, back in the TMI days in 1979 when that accident occurred, he often used robots to do all kinds of dose assessments, dose measurements.
When you talk about putting a cap through that whole area, what do you mean by a cap?
A cap is a well-designed, impermeable cap. What that is various levels of compacted in lifts soil to a permeability of about 10 to the minus 11. And you do that in 8-inch lifts, and you build it up. If it calls for whatever the size is, it may be a 4-foot thick cap. Then you put on the layer or on the cap typically maybe a 40 mil plastic, and then sand, and then topsoil, and that's it. It's a big. You create a big cap over the whole contaminated site. It's an interim measure, but it probably would last on the order of 100 to 150 years. It just depends on the design specifications. Oak Ridge National Labs, to kind of give you an idea of some of the contamination out there, the other sites seem benign as compared to Oak Ridge National Labs. Back about 5-6 years ago, we were actually down at the bottom of a drainage field, and I believe it was a tritium field, and we were actually building a big French drain down at the bottom where the groundwater flow goes. It was down over the hill, and we were building this big French drain that eventually directed the groundwater to flow into the ion exchange system. The ion exchange system would do its thing and discharge to the creek. Well, the trees around there, we established our control zones for radiological protection, and as we did that, your support zone is supposed to be clean and free of any contamination. And then the wind would blow, and the leaves would blow into our support zone, and the leaves were hot, were more contaminated, and had more source, more activity than the actual sources we were using to calibrate or source check our instruments that day. So I mean, there really is truly some problems out there, and as a consequence, they're having to do some measures like that and capping off the large areas like that.
When you calibrate these large mobile counters, how do you do that? With sources or?
Well, there's area correction factors that we use. We use sources, and there's area correction factors. You know, it's like, for example, the source may be, there's typical sources. Standard sources are like 58 centimeters. A lot of our probes are and are 100 centimeters. So you do the area correction factor that way. Everything that the standards that are out there, the cleanup standards for if this table is contaminated, it's all disintegrations per minute per area, per 100 square centimeter. Okay, so it's DPM per 100 square centimeter. So we want to calibrate our instruments to 100 square centimeter area, so it's apples to apples when we quickly do our numbers. But often we don't have that luxury because our sources are, half that or so, 58 centimeters. So we do an area correction factor to get us up to that 100 square centimeter number. It's a correlation factor. So our technicians are trained to do that. They're not nuclear engineers. So we have to make it as easy as possible for them, and it's something that they understand. Yes?
Yes, the question is, you were saying you're looking for 37 nuclear engineers. What level, education level, where you're looking at, and if you're looking at the virus like Pasteur, what kind of research are you guys getting into?
Very little research right now. We just finished let me answer your first part of the question. Undergraduate and master's level, sir. We have master level nuclear engineers in our organization. Wes knows, Dr. Himes knows about Ed Walker, for example. He's an Ohio State master's nuclear engineer. He's also a certified physicist. Ed's utilized all over the country. In fact, he's up in Buffalo at one of our sites up there doing some work. The other research projects we get into, often there may be research projects for our own means, but an example of where Ed again was used with some other scientists out at Oak Ridge National Labs was to design a neutron monitoring system for the border control down in Mexico that can detect weapons, both any type of sharp object, and also nuclear detection. So that's about as much as I know about that project. There's an example where we entered into an agreement with the Department of Energy and actually performed some research. That project I have, I really don't know a great deal about, but that's an example of what we get into, certainly. Another one that I remember was back in the Building 200 area of Hanford. We went down and we actually did using some chemistry that we had to pump into a hot cell piping system. We actually removed about 6 curies of material in a hot cell over the course of a couple of days using this chemistry material that we pumped in, slurried around, and we were trying to remove the scale material that's been built up over the course of the last 40 years. They've got a couple, 3-4 million linear feet of piping there that they have a serious problem with. They have a lot of leakage, they have a lot of exposure issues, things like that, so they were looking for somebody to come in and do that. We did that demonstration project. So there's many things that we get involved with. Some high-tech, some low-tech. You don't have to be fancy with what we do necessarily. But criticality design is something we get into, and that's something you all, I'm sure, are very familiar with. Any other questions? Anyone?
Any more questions for our speaker? Just thank Mr. Leichtweis. On the second floor.
Okay.
And meet the students.
Okay. I thank you. Outstanding. Perfect. That's down on the second floor? Yeah, skip lunch, so that would be great.
Enjoy the gift. Yeah.
Great. Well, it gives them an idea what some people do. You can